This lesson is going to focus on specifically rationalizing the denominator of a fraction because the denominator has a radical in it. And the process of fixing or simplifying a fraction that has a radical in the denominator is called rationalizing. And so this is going to be our lesson today. This is also lesson 2 from chapter 10. So if you're following along in order, this would be my second lesson. All right, now remember, the simplest form of a fraction means that there can be no radical in the denominator. So you have to do what's called rationalize to get that out of the denominator. Now, I've already gone through in the previous lesson, lesson 1, if you want to look that up, the quotient property. And so I'm going to talk to you a little bit about that today. Most of my fractions are already set up that way. So what I want to do is just quickly address that if these were not written in their own square roots, so let's say you started with the square root, 1 square root, and inside is a fraction, 10 over 3, you can split it up this way. But check out lesson 1 for that property. And so here we go. A method used to eliminate the radical from a denominator of the fraction is called rationalizing. Rationalizing. Now, there are a couple steps. It says step number 1. What we're going to do is multiply the radical expression by the value of 1, but it's not actually going to be technically looking like the number 1, but it is the number 1, because what we're going to do is multiply our fraction by a radical over a radical of whatever the number is that's in our denominator. And the reason why I put this here, like how did you pick square root of 3 for square root of 3? Well, it depends on whatever the denominator is that you have. And so what we're going to do is multiply by 1 to our fraction so the actual value doesn't change. But what we're going to do in the process is called get the denominator no longer a fraction, so rationalize it. And so what I'm going to do is multiply this fraction by 1, but not the number 1. I'm going to multiply by 1 that is a square root of 3 over the square root of 3. And the reason why I picked the 3 is because that's what's in my denominator. Now what I'm going to do is simplify. And simplifying just means now do what you're saying you're going to do. So what I'm going to do is multiply. Now look at this right here. If you have a radical 10 and a radical 3, you can multiply the 10 and the 3 together because they are alike. They have the same quality. They're both a square root. And so what I'm going to do is take my 10 times my 3. So when you multiply a fraction, you want to multiply the top times the top and the bottom times the bottom. Now the square root of 3 times the square root of 3, I can multiply these 3's together because they are both alike. They're both underneath the square root, which means I have 3 times 3. Now I'm going to simplify that multiplication that we just did. 10 times 3 is 30, so I'm going to rewrite this as the square root of 30. And the square root of 3 times 3 is the square root of 9. And the square root of 9 is 3. And that is your final answer. So it is simply getting the denominator to have no more root, no more square root symbol. Okay, so here we go. The second one here, rationalizing would be multiplying by whatever the radical is in the denominator, and you're going to multiply that by the top and the bottom. Okay, so 2 times 6, I can multiply those together because they're both inside of the radical, and I get 12. 6 times 6 would be 36. Now what I'm going to do is simplify the denominator. The square root of 36 really is the number 6. Now, here you would technically be done if you couldn't do some reducing. And what I mean is, not the 12 and the 6. You cannot reduce the 12 and the 6 because the 12 is under the square root symbol. And the 6 is not. The 6 is an integer, and the square root of 12 is not an integer. It's not a whole number because it's stuck in that square root. So you cannot cancel the 12 and the 6 because they're not alike. But what we can do is simplify the square root of 12 to bring out the integer that's kind of hiding in there. So this is what I'm going to do. I'm going to simplify the square root of 12 by pulling out the perfect square that I know is in 12. The highest perfect square that 12 is divisible by is 4. Now watch. The square root of 4 is 2. And now I can simplify this 2 and the 6 because they are both integers. They are alike in their term. So if I reduce my 2 and my 6, I have 1 square root of 3 over a whole 3. Now again, I'll repeat myself. Just like I did here, you cannot simplify the 3 under the radical with the 3 that's not under the radical because they're not alike in their term. You could only simplify if you can break out a perfect square from your square root. Okay, now number 3. I'm going to, again, do the same process that I did here because my square root of 6 is in the bottom. I'm going to multiply by the square root of 6 over the square root of 6. Notice how this 4 is not inside of a radical. So it has to stay outside of the radical because it's an integer of 4. And so I'm going to leave it as the whole 4 in the square root of 6. On the bottom, the square root of 6 times the square root of 6 is 36. Now, if I simplify this square root of 36, as that's a perfect square, this is what it will look like. Okay, so now let's see if we can do some simplifying. This 6 is a whole, it's not under a square root. This 4 is not under the root, so because they are alike in their term, we can reduce the 4 and the 6. I cannot simplify the 6 here and the 6 here because this 6 is stuck under the radical and this one is not, so that makes them not alike. But if I reduce, 2 goes into 4 twice, 2 goes into 6 3 times. This would make my answer 2 square root of 6, I didn't do anything with that, over 3. And that's my answer. Now, if you think you're getting it, you can go ahead and fast forward and skip this section here. But I'm going to keep going if you want a little more practice. What I'm going to do is multiply and rationalize the denominator by using whatever that denominator is. So now I have 12 times 5, which is the square root of 60, 5 times 5, which is the square root of 25. Now the square root of 25 is a whole 5, no longer under the radical. Now the last thing I need to do, if I can, so since there's no more square root in the denominator, I've kind of fulfilled that problem that we had of needing to rationalize. Now I just need to see if I can simplify my square root of 60. Is there a perfect square that 60 is divisible by? And the answer is yes. 4 times 15. The perfect square of 4 times 15 is 60. And now what I want to do is simplify that square root of 4 piece. That is a whole 2, no longer under the radical. And this 5, no longer under the radical because we had simplified that. 2 and the 5, now that these are outside, if I could reduce here like I did in this problem number 3, I would, but I can't because 2 and 5, there's nothing in common there. That's my problem. That's the end of what my problem can be. 2 square roots of 15 over 5. Now, again, number 5, multiply by whatever the radical is that you have in the bottom of your fraction times the top and the bottom. So technically we're multiplying by 1 because square root of 8 divided by square root of 8 is 1. So I'm not changing the value of my fractions. So the decimal answer is remaining the same. I'm just making it look better, so in a form that's acceptable. 3 times 8 is 24. 8 times 8 is 64. And we know what the square root of 64 is. It is 8. Now, if you can simplify the square root of 24, you need to do so. Is there a perfect square that 24 is divisible by? So think of the perfect square list. 1, 4, 9, 16, 25, 36, and so on. One of these numbers, 24, is divisible by. and it's 4. So now I'm going to simplify the square root of 4. That's a 2. Now that my 2 is simplified for the top and my 8 was simplified from the bottom, because these are no longer under the radical sign, they are alike, I can reduce here. 2 and 8 can simplify to a 1 and a 4. Now, at the top, I'm going to have 1 radical 6, but the 1 is unnecessary to write. You don't have to write it. I wrote mine in pencil because technically you can erase that and it's exactly the same answer. In fact, I normally wouldn't leave it like that. I would normally go back and just write it square root of 6 over 4. But that's our simplification. The 6 and the 4, we cannot reduce those because the 6 is under the radical and the 4 is not, so they're not alike. You cannot reduce those. All right, the last one here. Before I multiply by 27, because that's kind of a big number, I'm going to do a little bit of simplifying before I multiply the bottom. So I want to show you some simplification in case you have kind of larger numbers. So then you don't have 27 times 11 and that's like a giant number. So here we go. What I'm going to do is simplify this radical on the bottom first, so that I only multiply by what I need, not more than what I need. So let me show you this. I'm going to rewrite this as, instead of 27, I'm going to rewrite this as a 9 times a 3. And the reason why I'm doing that is because I want to break 27 down because it's such a big number. And I could have done that here, I didn't, but I'm going to break down the bottom square root first. Now, here we go. The square root of 9. 9 times 3 is 27, and I picked 9 because it's in my perfect square list. The square root of 9 becomes a whole 3, and the square root of 3 is still left. So instead of multiplying by the square root of 27, I don't need to multiply as much to rationalize. So in this case, to rationalize, I'm only going to multiply by, instead of 27, the square root of 3. That way I can fix the square root that's just the only part that's my problem, the root in the denominator. So now for the top, if I multiply 11 times 3, I get 33. This 3 that was outside is still there. Square root of 3 times square root of 3 is square root of 9. And now I have, if I simplify one more time, this square root of 9 is going to pop out an additional 3. So this square root of 9 makes this 3. And now, if I multiply my 3's together on the bottom, I get 9. There's number 6. I feel like that was the hardest one on the page. Okay, now, here we go. Back side, and we're done. I'm just going to go through a bunch of rationalizing the denominators. If you feel like you're getting it, go right now, finish the homework assignment that your teacher has for you, and check back in for our last lesson on radicals tomorrow. All right. Again, this is just purely for extra practice. If you feel like you want to skip ahead and just look for one that you think you want to see, so one of the harder ones at the bottom, feel free to fast forward as well. All right, I'm going to start with number 7. I'm going to multiply by the square root of 10 over the square root of 10. 6 is not inside a radical, and 10 is. And so I cannot multiply the 6 and the 10 because they're not alike. So it's just going to be, when I multiply, a 6 times a radical 10, not a 60. But on the bottom, because 10 and 10 are both inside of the root, I'm going to make that 10 times 10, or 100. Now for the numerator, my 6 radical 10, I'm going to have that stay as it is. And my square root of 100 is really 10. Now I have a 6 that's outside of the radical, a 10 that's outside of the radical. If you can reduce, make sure you do that. 6 and 10 are both even, so I'm going to reduce by dividing the 6 by 2 and the 10 by 2. And this would be your correct fraction. So the most simplified way of writing 6 over the square root of 10. Now number 8, we have square root of 20 over the square root of 6. I'm going to multiply by square root of 6 times square root of 6, top and bottom. 20 times 6 is 120. I can multiply these together because they're both under the radical, and 6 times 6 for the bottom is 36. Okay, so I have square root of 120. Square root of 36 is really a whole 6. Now I need to see if I can simplify the square root of 120. What is the perfect square, the highest one, that 120 is divisible by? It's 4 times 30. 4 is the highest perfect square that goes in. Now I'm going to simplify the square root of 4. That's 2. And now that my 2 and my 6, they're outside of my radical, I can reduce that here. 2 and 6 reduces to a third. You don't need to write 1 radical of 30. You can just write radical of 30. And then if I reduce by 2, the denominator is now 3. Great job. Now I have number 9. Multiply your top and bottom by the square root of 5. 10 is outside, 5 is inside, so leave it exactly like that, outside and inside of the radical. 5 times 5 is 25. And now 10 square roots of 5, I'm going to simplify the bottom, which is why I did this. That's a 5. Now 10 and 5, we can reduce this. So I have 2 square roots of 5 over 1. You don't really need to write over 1, so I'm just going to write 2 square roots of 5 as itself. If you feel like you're getting it, go ahead and move on to your homework. For number 10, multiply by the square root of 2 over the square root of 2, and you get 3 square roots of 2 over the square root of 4, or 3 square roots of 2 over 2. Now this one, there's nothing else I can do. This 2 inside the radical, this 2 outside the radical, we can't simplify those, and so that's it. 3 and 2 can't reduce, 3 halves. That's as low as you can get with your fraction, 3 halves. Number 11, multiply by the square root of 8 over the square root of 8. Here I have 9 square roots of 8. Now, if you've noticed, you can maybe skip a step. I'll say skip a step by just calling this 8 on the bottom. Maybe you want to jump there right now. This would be the square root of 64, which is really 8. Now, if I can simplify further, I should. This square root of 8, I can actually break down because there is a square root in an 8. I'm sorry. There is a perfect square that we can divide out of that square root of 8. So I'm going to change the top to be, instead of square root of 8, square root of 4 times square root of 2. Now the square root of 4 I can simplify, which is why I'm doing this. I have 9, square root of 4 is 2, and then this square root of 2, I can't do anything with that. And then our 8. Now if there's anything we can reduce, we should do so. My 8 on the bottom, my 2 on the top can reduce. So I have 9 times 1, which is 9 square roots of 2 over 4. The 2 and the 4 cannot reduce because the 2 is inside the radical, 4 is outside the radical. All right, now number 12. Multiply by square root of 3 over the square root of 3. This is going to be 6 square roots of 3 over the square root of 9, which really is 3. 6 can divide by 3. These are both outside of the radical. 6 can divide by 3. That's 2, or 2 square roots of 3. You could write it over 1, but it's unnecessary. You don't need to do that. Okay, number 13. Our quotient property from the previous video that you watched says that I can split up my fraction into 2 separate radicals. Now, I can't reduce the 2 and the 45, so I'm just going to leave it as it is. If I could have reduced at this point, I would have, but 2 does not go into 45. So now what I'm going to do is multiply here by the square root of 45. Okay. 2 times 45 is 90. 45 times 45 is 45. Now, is there a perfect square that 90 is divisible by? Can I simplify that square root of 90? And the answer is yes. 9 goes in here. And what is the square root of 9? It is 3. Can 3 and 45 be reduced? Absolutely. 3 goes into 3 once. 3 goes into 45 15 times. So my simplified fraction is 1 square root of 10 over 15. All right, moving right along. Number 14. If I multiply by that radical on the bottom, I'm going to have 5 times 2, or the square root of 10, over the square root of 2 times square root of 2, which is square root of 4, and square root of 4 is 2. Now for this one, my 10 and my 2 can't reduce because the 10 is inside the radical, the 2 is outside. And I can't break down the square root of 10 because there's no perfect square that goes evenly into 10 except for 1. So 1, 4, and 9, that's the beginning of my list. 10 is not divisible by 9 evenly. 10 is not divisible by 4 evenly. So that's it, I'm done. For number 15, only multiply by the radical piece that you need. You can kind of ignore the 5 for a second. So only multiply by, actually, I think I see something else. Isn't this 4 inside a radical, and isn't this 2 inside of a radical? Could we do something like this? I'm not going to rationalize this one the same way as I've done the others. Watch. Isn't it true that the square root of 4 is the same as square root of 2 times square root of 2? Right? Isn't 4 the same as 2 times 2? And the bottom has a radical 2. I could break it down like this, and now I have left square root of 2 over 5. Haha, that's so cool. If you did rationalize like I did the others, it would look like this. We had square root of 4 over 5 square root of 2. If we rationalize like we did every other problem, we'll still get this same answer. I promise, I'll show you. Multiply by the square root of 2 over the square root of 2. And then we'll get 4 times 2, which is 8 underneath the radical. The 5 is outside, so that stays. Inside of the radical, the 2 times the 2 gives us square root of 4. Now, I have the square root of 8. The 5 was outside of the radical. The square root of 4 is the number 2. Now in the bottom, if I multiply these together, I'll have square root of 8 over 10. Now watch, I'm going to get here, I promise, I'll show you. What perfect square goes evenly into the number 8? And that radical is a 4. The square root of 4 is 2. And 2 and 10 can reduce to 1 over 5. So definitely a little bit more steps for rationalizing, but if you can see that you could do some canceling because 4 and 2 are both inside the radical, if you could reduce first, it's a lot easier. And so make sure you reduce if you can. Just makes for less work. All right, 2 and 27. I cannot reduce here. So I'm going to have to separate these out. A 2 with a radical and a 27 with its radical. Now, like I said before, if you can do some canceling, it would be really great. So if you don't multiply more than you need. And I'm going to show you how to do that here. The square root of 27 I can turn into a number and a radical. So I'm not going to multiply by 27 because it's just multiplying by more than I need. Kind of like what I did here. I didn't really need to multiply by square root of 45. I can multiply by just the radical that I need. So I'm going to show you how to do that here. The square root of 27 can simplify down to the square root of 9 times 3. And I'm using 9 because it's a perfect square. Now if I simplify that, I'm going to have square root of 2 over 3, a whole 3 from that square root of 9, and then the square root of 3 that's left. Now, this whole 3, I don't need to multiply by. I just need to multiply by the piece that's the radical that's my problem. So I'm not going to multiply by like I had before, the 27. I'm going to multiply by now only the 3 that I need. This will help me not have to reduce later on because I multiplied in more than I needed. The 2 times the 3 means we'll have square root of 6 on the top. The 3 that was outside stays. Square root of 3 times square root of 3. Because these are both under the radical, I can multiply them together. And now, this square root of 9 really is the number 3. So the denominator simplified would be 9. Oops, I'm saying 9 and I wrote 9, but the top had a 6. Good thing I caught that. So square root of 6 over 9. The 6 and the 9, even though they have a 3 in common, you can't reduce there because the 6 is inside of the radical and the 9 is not. All right, number 17. The top I notice is a perfect square. And what I'm going to do to start is simplify that to the number 4 over 3 radical 2. Now, only multiply by the radical that's the problem. And the radical in the denominator, that square root of 2, that's what we're going to multiply by. Square root of 2 over square root of 2. The top is going to be 4 square roots of 2. The bottom, I have a 3 outside. This square root of 2 times this square root of 2 makes a square root of 4. And now if I keep simplifying, the square root of 4, I know what that is. That's 2. Now I can reduce here. I notice I have a 4 and a 2. I can do some reducing. Now I have 2 radical 2 on the top, 3 times 1, or 3. All right, very last one. Thanks for hanging in there. 6 and 50. Do these have anything in common that we could reduce first? I notice they're both even, so I'm going to simplify that before I start. Okay, watch. So I broke this up because they were both even. I broke it up into a square root of 2 and a square root of 3 because 2 times 3 makes 6. I know 50 is even, so I broke it up into the square root of 2 and the square root of 25. These are exactly alike, so I can cancel them out. Now I have, if I cancel them out, 3 square roots of 3 over the square root of 25, and I'm super excited about this because I'm basically at my answer now. Square root of 25, boom, 5. Thank you so much for watching my video. Like, subscribe, you know, all that stuff. Or not, totally fine. I hope you're well. I hope you're safe. I hope you're going to have an awesome rest of your day. I wish you all the best.